Welcome to IT 3000, Episode 21. Today we're going to unpack one of Unix's most quietly powerful ideas, the mount operation. Forget drive letters, forget C: and D:. Unix gives you one single tree, and mounting is how you graft new file systems onto it. By the end of this, you'll have a precise mental model of what actually happens when you type that command. So let's pin down the concept precisely. A mount attaches a file system to some directory that already exists in the tree, and from that moment on, anything inside the mounted file system is reachable through that path, transparently. The applications walking that path have no idea they've crossed a boundary. And here's the part worth underlining. A mount moves no data at all. It simply changes where a path lookup goes next. Every mount you'll ever perform decomposes into the same four pieces. There's the source, usually a block device or a network share, though with TMPFs it's nothing but memory. There's the mount point, an existing directory whose contents get hidden, not destroyed, and quietly reappear once you unmount. There's the type which tells the kernel which driver should interpret the bytes, ext4, xfs, ntfs, nfs, because it genuinely can't guess. And then the options, flags like row, no exec, no suid, no dev, which act as a real security boundary over everything beneath that path. So how does a mount actually take effect? It happens during path lookup. When you open a file, the kernel starts at the root and walks the path one component at a time, and at each step it asks a simple question: is this directory a mount point? If it is, the walk jumps sideways into the root of the mounted file system, and from that point on, a different driver interprets the bytes. Same interface, different format. The result comes back to your application, which never sees the seam. That's the virtual file system layer in action. One interface, many formats, chosen mid-walk. That lookup redirection has a consequence people usually meet the hard way. Picture this. You add a dedicated disk for var log, mount it, and life is good. Months pass, a reboot goes a little differently, and some service writes log files before the mount runs. Those writes land in the plain var log directory on the root file system, and then the mount drops on top and hides them. Now df shows var log almost empty while your root partition mysteriously fills up, and ls in the folder shows nothing to blame. Unmount the disk and the phantom files reappear. The space was never lost. It was simply underneath something. Now, mount has two close cousins that get confused with it constantly, and the distinction matters. A plain mount attaches a file system, a new source, a new type, its own options. A bind mount is different. No new device, no new file system, just an existing directory made to appear at a second path. It's how container runtimes assemble a root out of pieces of the host, and a symbolic link isn't a mount at all. It's a small file whose content is a path followed on every lookup. The application can see the link, inspect it, and choose whether to follow. That visibility is the tell. Mounts are invisible redirection, symlinks are visible indirection. With that distinction in place, it's worth pointing to where the story goes next. Mounting sits at the center of a whole cluster of concepts. The VFS layer that makes the redirection possible, fstab that declares mounts persistently, network file systems like NFS, memory-backed file systems like TMPFs and mount namespaces, the mechanism that lets containers see an entirely different tree than the host. Each one is a natural next step. But the immediate next episode is the virtual file system itself, the kernel machinery that made everything we just discussed work. So to leave you with the mental model, a mount has four parts: source, mount point, type, and options, and treat those options as a security boundary, not a matter of taste. Remember that whatever lived at the mount point isn't gone, it's just shadowed, waiting to reappear on unmount. And the whole trick works because mounting redirects path lookup, no data moves at all. Hold on to that and you're ready for the VFS episode. Thanks for watching.